Hello everyone, I'm Eddie Joe. Today I'm going to talk about the capacitor and direct current. First, capacitor is like a battery. It's a device to store electrical energy. It stores energy by electric field, and a battery stores by chemical energy. So they're a bit different. So its storage potential is called capacitance. Its unit is called farads. A 1 farad capacitor means that it can store 1 coulomb of charge at 1 volt in a capacitor. So there are 3 parts in the capacitor: conductive plates, separation, and dielectrics. A larger plate increases area for the storage of charge, and also it increases capacitance by decreasing the separation. It is used in different ways. First, it is used to store charge for high-speed use and block direct current voltage, because after a steady phase, there's no a capacitor can be treated as an open circuit. It's an open circuit. No current can run through it. Capacitors are often used in radio tuning circuits, time circuits, high voltage application, and electric cars. These are the 5 main types of capacitors: air, mylar, glass, ceramic, and supercapacitor. Okay, we are now going to talk about indirect current. Unlike other applicants, capacitors has a different characteristics while placing it in a circuit. Contrary to others, the increasing level of capacitance can be obtained by placing capacitors in parallel, and while decreasing level can be obtained by placing capacitors in series. So this is the following formulas. Okay, we will have some example for calculation. First, this is a discharge phase, and we want to know about the VC, like the current at the instantaneous voltage at that time and the instantaneous current at that time. It is made up. The current can be calculated by using a formula called IC equals negative E, means the power supply, over the resistance times the E to the power of negative T to the RC. RC is called the time constant. It is made up of the capacitance times the resistance. In this case, it is 64 milliamps. It is because its resistance is 8,000 ohms, and the capacitance is 8 mil ohm. Yes, so the current is 1.84 milliamps, and the voltage is E times the power times the E to the power of negative T to the against the time constant. So it is 14.7 volts. And also we have a charging example. This is a working of the charge. It's because it's a bit different from into calculations. For the current one is very similar, because the E is just the discharge of the current minus. Yes, we just need to remove the minus side This will be the answers. The formula will be the same. But for the voltage, it's a bit different. In this time, E has to times a bracket over 1 minus e to the power of negative t against the time constant. It is a 1 over. So when charging, after charging for several minutes, the time and mostly it will enter a steady stage and the voltage will remain the same. This is the reference, and I hope you enjoyed my presentation.